Okay, so this is a quick video to show you the details on my tank and more specifically the details on my new light that I've been building. If some of the people have been following me on Facebook and whatnot and on the forums, you'll have noticed that I've been building a new light. So I wanted to make a video, summarise it all and answer some questions. So up the top here, this is the lid itself. It's got around the edge here, this is plexiglass, and in the middle this is a sheet of aluminium that has been painted. You can see I can actually remove these screws here and I can take the piece of aluminium out of the middle to service the LEDs if I need to. So it's got a fan in the middle and that is controlled by a temperature controlled computer fan controller thingy. At the back here we have a hole and there's going to be like an automatic feeder that goes on here and that's where the food's going to drop in. Obviously at the sides here these are vent holes for the fans. So we've got one fan here and we've got another fan over here. This fan here, this piece of plexiglass is removable and that goes directly into the tank. So that's down there is the surface of the water. This fan blows into the cavity where the LEDs are. So if I put my finger in there, I touch the surface of the plexiglass that's underneath it. Then, so the air goes in there through the cavity and out of these holes here. Same over here, it goes in through the cavity and out through these holes here. This fan here blows air in here, comes round and goes out of here. That's also my protein skimmer, and that's pretty much it for the lid. One more thing to note is along the top of the lid on the inside here there is an LED strip which is connected to one of these. So when the lights go off at night and I don't want to turn on the main light, I can turn this on and it just provides just enough light to look for critters and things like that. Well, what I'll do quickly, I will open the lid and show you inside. I don't know how the camera's going to work with it because it's very bright, but I will show you it. So as you can see here, you have to remove that piece to get the lid open. But that is what it looked like from underneath. So as you can see, this is plexiglass and there's obviously, you can see the cavity for the fan there. That is the hole for the feeder and that goes straight through to the top. And then you can see all the different colours of LEDs in there. I can, due to this lid being the size it is as well, I have full access to the top of the tank, which is great. Some of the other stuff that's in there, I've got over here, this is my sensor for my auto top off. I had to bend my own tube here to get the inlet for the water because there's not much space here. That's my skimmer, that's my little filter, that's where the water comes in for the auto top off. I've got two wave makers in there, one on there, one over there. That's about it really for the top of the tank. Okay, so this is the bottom of the tank. I've got up here, this is the controller for the LED. And I've got a little dial here and the screen comes on when you do it. I'll take a closer look at the program of that in a minute. These are the two controller boxes for the wave makers, so I've got easy access to them as well. Down there I've got my canister filter and I also keep the remote down there as well. And this plate here is also mounted on like magnets so I can get to all the electronics behind it. So let me just take that off quickly and show you that. Okay, so in here it's quite hard to see, but over here this is the main controller box for the LEDs. That's where the power supply is, all the dimmers and whatnot. I've got up here, this is the power supply and these are the relays for my auto top off, which is also, I've done that myself. I might make a video on that as well soon. There is the power supplies for the two wave makers behind there, and then right at the back there are the power outlets themselves. Yeah, pretty much like any cell really, all the wires are a mess. Okay, so I've got one more thing I need to show you, and that is up here. That is the fan controller, and I've got little dials here where I can turn the fans on and off. It also gives me the temperatures that are in the tank. That's the water temperature. Well, it's not the water temperature because the probe's here. I've still got to fit the probe, but that's going to be the water temperature, and that is the temperature in the lid. And I have actually done lots of tests with the fans and whatnot, and the fans actually lower the temperature inside the lid and inside the cavity where the LEDs are by at least 10 degrees, so they do work really well. So that's about it for the setup of the tank and what I've got itself. What I'll do now is I will talk a little bit more about my LED and how I made it and whatnot. Okay, so I suppose the first question that people are going to ask is why build your own light? And for me it's a very good question, and for me the main reason was I wanted a closed lid on the top. I don't like the light leak that you get, although I do get a little bit of light leak. See on the wall here, there's a little bit through the holes, but it's nowhere near the light leak that I would have had if I'd have had like a kettle or something like that hanging above the tank, shining directly onto the water surface. So I don't like the light leak. Another reason is I've lost fish as well before through jumping. I've had a fish jump out of the tank and you wake up in the morning and it's lying on the floor, dry. It's not nice. Second reason is my old lid was getting a bit tatty, and it also didn't provide me with good access to the inside of the tank. So I only had like a short flap at the beginning, at the very front piece of the tank where I could get to. I also didn't want shadows in the tank. So if you have a light hanging above the tank quite far up, you're going to get shadows where the light isn't directly shining on. So what that means is I want the LEDs to be spread out over the entirety of the lid as much as I could get them. And that is pretty much what I've done here. As you can see, when I open the lid, the LEDs go, there's like that much gap between the glass and where the LEDs start, meaning that I have no shadows on the front. It's pretty much a nice, consistent light. Wow, I need to clean the glass. There's pretty much a consistent light all the way across the tank. Now, a combination of these two reasons basically means I had to build it myself. There's nothing on the market that provides a closed lid, no shadows, and fits my tank. There's nothing on the market that do it. I'd have to build something myself. And what I started doing is I started looking around on the internet, and I came across a forum thread on Ultimate Reef by a person called Perkint. I'm hoping I'm saying that right. And they basically made the first version of the controller that I've made. I've pretty much made the exact same controller. I've made a few little modifications and built it slightly differently, but essentially it's the same controller. If you're interested in making your own light, I highly advise you go over to his forum thread. I'll link it in the description below, and just have a read through it. It's quite a long thread, and you'll see some posts from me in there as well, but it's well worth a read. Okay, so what I'll do now is I'll go through a quick walkthrough of the circuit diagram. So let's get that on the screen now. This is the circuit diagram. At the bottom middle, you can see there's a screen with its onboard controller. To the left, we have a representation of one of the dimmers with some LEDs, but obviously in the final version there's going to be a lot more of these. Between the two of these, there's the temperature sensor. I decided against using this, and I'll explain why in a minute. At the top left, you can see the PWM output board, which basically splits the outputs to get more consistent output on your PWM, which controls the dimmers. At the top, there's the clock module. Below that is the Arduino itself, and to the right of the Arduino we have the encoder with a push button, and there's also a little cooling fan shown there as well. Now, I opted to wire the LEDs in series, meaning that you have a positive going to an LED, and then the wire from that LED goes to the next LED, next LED, next LED, next LED, all the way around until you get back to the minus. It has its upsides and its downsides. I just opted to use it that way. Basically, the biggest downside is if one of the LEDs breaks, it breaks the circuit and they all go off. That's the biggest downside. Plus sides, you need a lot less wire because you're using less connections. And I already used, the way I built it, over just between inside the lid and the connection from the middle of the lid to down here, there is over 30 meters of wire. So if you'd have done it in parallel, it would have been a lot more. The upsides means I can use a bigger power supply to control the LEDs. It makes it more simple to do it that way. So basically I've got a 24 volt supply powering LEDs that are only running on, like, I think the average is like 3 volts, 3.4 volts or something like that. You need to use resistors to obviously limit the current, and how I calculated that was a website called ledcalc.com, and I'll give you an example here. I wrote it down, I'm going to give you it, but basically the easiest way to do it is put in all the values into this website, and it basically just tells you what to buy, tells you the parts, tells you the resistor that you need to buy. I'm just going to read the example I have off the sheet here, and I'm going to read it, it's going to be really boring. So for example, the royal blue LEDs need 3.4 volts. Now I have a 24 volt power supply, and if you divide 24 by 3.4, it gives you a value of 7.05. So that means I can have a maximum of 7 LEDs on the chain. Right, so now we know how many LEDs we need. We need to calculate the resistor value. So these LEDs need a current of 700 milliamps. So to calculate that, you take the source voltage of 24 volts minus the total LED voltage loss. So that would be 3.4 times 7, which gives you a value of 23.8. You take that and you divide it by the required current. In our case, 700. So you take the 23.8 divided by 700, and this gives you a value of 2.857. And now you obviously can't get a resistor with a value of 2.857, so you take the closest value available. In this case, it's 2.7 ohms. So that's how you calculate it if you really wanted to. But obviously, put it into the website, simple. Okay, so I'm not going to go over how you should build it. If you want to build it, every build's going to be different. That's the whole point in making one yourself. But I will tell you how I built it. So to start, I'll start off with the lid. I'm just going to pick you back up again. So obviously around the top here, like I said, we have plexiglass. This is aluminium. The aluminium acts as a heat sink, so this is actually quite warm now. This is aluminium, so this acts as a heat sink. But below this is a sheet of clear plexiglass, and that obviously lets the light through. Now what I'll try and do here is, through the magic of editing, I will get some, oh there they are, some CAD drawings, and I will show you basically what we've got in the CAD section. So if you cut the light down the middle, you can see the profile, and you can see that we have the aluminium sheet resting on this lip around here. Inside this lip there are threaded inserts which aren't really represented in the CAD drawing, but they're in there. And you can obviously see how the plexiglass is glued together to form the lid itself. Plexiglass is not a very easy material to work with. You have to be really careful when working with it, and obviously making complex shapes like a curved edge. There's a cutout over there, and obviously making all them shapes there it's quite difficult for one, and if you get it wrong and for some reason the plexiglass decides to splinter, that's it, all your work is ruined, you have to start again. So if you work in plexiglass, do it really slowly, be really precise in what you do, and just be really careful. To glue the plexiglass together, I use this stuff here, which is basically, it's an ultraviolet glue. So I cut all the pieces out in the basement, and then I brought them all up and glued it outside. And what this does, it sets in the sunlight. Within 20 minutes, this goes like, pretty much like glass. It makes a waterproof seal, and you can actually build up a fillet around the joints. So to mount the LEDs to the sheet of aluminium in there, I use this stuff here, which I just got off eBay, and it's basically a thermal glue. It comes in little tubes like this. I brought 4 of these tubes, and this is the last one that's left. So I've used like only just a little tiny bit of that. Now working with aluminium is also not very easy, especially with having the curve on the front like that. It is a bit tricky to do. Now I'm a joiner, so a lot of the tools I use are normal woodworking tools. I've got a little table saw, a little router, jigsaws, all that kind of normal woodworking tools, and you can use all of them tools to work both plexiglass and aluminium. So to build the controller itself, I split the design into 2 pieces. As you can see, I've got down here the screen and the little rotary encoder, and inside behind that I've got, in a separate box, I've got the power supply, the dimmers, and all that kind of stuff, all the stuff that you don't need to see. I've got all that behind the back. So I split the circuit into 2 sections, which I could build 2 separate things. So the first thing I built was the screen. What I did is I mounted the parts onto a bit of perf board, which is basically like a PCB with loads of little holes in it. So I mounted the parts onto that, and then I cut out around the edge to make it small as I could. I also used like an Ethernet cable to make the connection, so that I can actually unplug the controller from the other box inside. And the other part of the circuit, which houses the Arduino and the dimmers and all that, is behind there, and that's also on a perf board, which I didn't actually have to cut. And basically I built it in the same way. I've mounted the parts and thought about how I'm going to make the case as well while I'm doing that, and basically just put them all in, soldered them all in, and That's it. A couple of things to note on the little time lapse here is that I didn't add all the dimmers when I made the time lapse. The dimmers arrived at a later date. I had one dimmer arrive earlier so that I could do some testing, and all the other dimmers came at a later date. Now I also made some cases, as you can see. The case for the piece on the front here was made on my CNC mill. I have a CNC mill in the basement, and it's made out of like a POM plastic. So it's basically two shells glued together, and the front is a sheet of carbon fibre. I also glued in a little name here on it and whatnot, but make it look a bit more professional. Now the case is obviously, I made it like that, but it can be made anyway. If you've got a 3D printer, you could have 3D printed a case. I've just used what I had. And the second case behind there, the one that houses the power supply and all the rest of that, didn't have to be as pretty as the one on the front because you're never going to see it. So I made it out of the scraps of the black plexiglass from the lid. So basically what I did after that is it was pretty much all finished. I had the things in the cases, the lid was built and whatnot. So I put it on the tank, and then I started to figure out how to program it. So let's move the camera down here now, and I'll show you how. I'll just give you a quick walkthrough on how it's programmed. Okay, so this is how the screen looks normally. The light goes off after I think 5 minutes, but you have at the top here you have the LED time slot. You have the time itself. This is temperature controllers here, so mine set to error because I'm not actually using the temperature sensor. So that would be the temperature in the tank, or whatever the temperature sensor is connected to. That would be the PWM output of the fan, so it controls the fan speed. And that there is like the max percentage of the light. So if you want to acclimatize corals, you can say I want it to be 100% over the period of 5 days, and it was ramp up over 5 days. So if you push the button once, you get the LED time slots here, and you can go through them. So I have at the minute, how many slots do I have? 5 slots. So the first slot is 0. So at 8 o'clock, it fades for 122 minutes into the following values. So you go view, press it again and go view. And then I've got all the names of the LEDs here. So you've got white, white neutral, royal blue, blue, and the value below it is the PWM value, which goes to the dimmers. And basically it's the same thing. You set that up for each individual time, and then it basically does it. You have to remember that the last value is what it dims from. So at 8 o'clock, sorry, when I want the lights to come off, it takes the value of what you was last. So the last value would have been number 5 at 10 o'clock in the evening. It dims for 12 minutes into all zeros. So it basically turns off the lights. But it's not the simplest thing to program. Obviously newer lights are going to be a lot easier. They have phone apps and whatnot. But this is the sort of thing, you only do it once, set it and forget it. Okay, so you're probably wondering, what does it cost? And if I'm being honest, it's not cheap. It's not much cheap. Well, it's not cheap.
Okay, so while I'm editing this, I'm realising that everything I'm about to say is wrong. The building your own light is cheaper than buying one. But basically what I'm going to do now is I'm going to leave the video as it is because it's all edited and whatnot. And there are bits of information in there that are still valid. But basically anything that comes down to the cost is going to be corrected on screen in text from this point on. So just bear that in mind while you're watching.
Cheaper than buying a light, but I have the added value of I've got a lid as well as my light, so I have to take that into account. If you was just comparing it directly to LEDs, then it's not cheaper. It's much cheaper to buy your own LED. Well, it's difficult. I say it's not cheaper, but well, I'll tell you what, I'll just break it down into the costs and you'll see what I mean. So the parts for the lid themselves, the plexiglass, I'm going to read off a sheet here. The plexiglass, the aluminium, the glues and the screws and whatnot, all the stuff that I needed to build the lid cost me about 80 euros. So all the price is going to be in euros because I'm obviously in Germany. The LEDs themselves cost me about €173, and I will leave a link in the description to where you can get them, but I brought them from a shop called LED One in Germany. It's an online shop and they make the LEDs. So this is where I'm going to have to read off because I listed all the stuff down here. The electronic components for the controller, what they cost. So we have $41.20 for the driver. So I have 8 drivers and they cost me $41.20. 5 for the PWM module. 3 for the PCB that it's all mounted to. $390 for the rotary encoder. $365 for the clock module. $765 for the screen. $375 for the Arduino, $26.90 for the power supply, the 24-volt power supply, $16 for connectors. I used XT30 connectors to make the connection from the lid to the controller, and about €2 for resistors. So if you add all that up, it comes to about a total of €113 for all the parts to make the controller. Now, there's also about €25 in things like wire and connectors and thermal glue and all that kind of stuff. There's about €25 for all the other little bits and bobs. Now that brings the total of the whole thing up to about €391. So I'm just going to round it up to 400 for simplicity. To me, that seems okay because I've now got out of that €400. I've got a new lid. I've got a light which is producing great colour and whatnot. Some of my corals are actually starting to change colour. So I'm happy with it, but it was a risk, and what I will do now is I'll break it down into the cost per watt. So we're just looking at if it was just the LED. Taking out of the equation that the fact that I've put it's a lid as well. So I have about 125 watts of LED power, and if you divide that by the 400, you get a value of about 31 cents per watt of LED power. So that's for my light. Now if you compare that to some of the more common brands, some of the well-known brands which produce really good light and really good spectrum, I've got one of them written down here. I've got the Ecotech Marine Radion XR 30 watt G4 Pro. Now that's a long name. Which has a max LED wattage of 190 watts. Now that costs €900, so you're already, if you're deciding on buying that, you're already making a much larger investment in your light. You're obviously getting more for it. You're getting more in the wattage area, but it's a bigger investment initially. So if you divide the 900 by the watts, you get a value of about 20 cents per watt. It's about 21 cents per watt. So it's a little cheaper, but obviously I've got a lid. If you compare it to an AR Prime HD, which has a power of 55 watts and costs €300, so you're now you're investing less. You're only investing 300, but you're getting less in the power of the light itself. You're only getting 55 watts. Again, this is a centralized LED, so it's one light in the middle which is going to spread over the tank. So you'll have a powerful section in the center, and down here in the tank I might have some shadows because the light can't get around the rock. But that light there, if you do the same calculations, you get a wattage cost of about 18 cents. So that's even cheaper. So my light isn't cheaper than buying your own light if you're just comparing the cost per watt, but my light has other advantages that a normal off-the-shelf product doesn't have. I like the fact that my light is serviceable. If something breaks on my light, I can physically open it up, change an individual LED out, which costs me €1 or €2 max, and I can actually physically repair my light myself. The positives for me on having a light like this is I have a full spectrum of light around the tank. There's a uniform light all the way around the tank. I obviously have full dimming control, although it's not that easy to program, but you set it and forget it. I also have a closed lid on the top, meaning that I'm never going to have a fish jump out because it's not going to get through the lid, and it's what I wanted really. The downside is it's obviously not cheaper. You have to build it yourself. It's not that simple to build. Getting the controller to work and all the soldering right and whatnot It's not something that anyone can do. You've got to have some previous soldering experience and whatnot, but it is possible. It's not the simplest thing to do, but it can be done. Another thing which I look at as a negative, but it's also not really a big negative for me, is the fact that this doesn't have any sort of Wi-Fi capabilities. If you buy a new light, it has an app and you can control the whole light through your app on your phone, which I think is great. Although, do you need it? That was a thing for me. It was like, do I really need that? Am I going to use that every day? And the answer is no, I'm not. I'm going to set the thing up and I'm going to forget it. I'm going to leave it as the setting that I want, because I think the most important thing for corals is consistency. Water quality consistency, and also the lighting consistency. If you have the lights come on at different times in the day, it's not going to do them any good. Another big thing which for me was a risk is I didn't know how the tank was going to react to the light itself. I didn't know if it was going to be too powerful and burn all the corals. I didn't know if it was just going to make all the corals go brown. I had no idea. It was a risk. I didn't know, but I used information that was commonly available and put in basically the best components that I could. And for me, it did pay off. For example, this little acro at the top here, it's actually gone from a brownie colour, like a really dark brown, and it's going pink, and it's only doing it because of the light. So the light really does change the quality of your tank. Okay, so I think I'm going to leave it there. I hope I've included enough information and answered any questions that people are going to have. If I haven't answered your questions, then if you're watching us on YouTube, there's obviously the comment section down below. Comment on the video and I'll get back to you. If you're watching this on Facebook, I've got a Facebook page where I post like little updates. I also, if you've been following the page, you would have known that I was making this. But if you're on Facebook, drop me a message on there or comment the video or whatever, and I will answer your questions. What I'm going to do now is I'm going to clean the glass for one, which I should have done before we started filming this video, and then I'm going to give you some close-ups of some of my coral, which I think is a nice way to end the video.